Hello, George Romanic here. Welcome to Fundamentals of Weather and Climate playlist. In today's video we are going to discuss the concepts of longitude and latitude, and we will talk about tropics, subtropics, mid-latitude and polar regions. Let us start by defining the concept of a latitude. If this is our spherical planet Earth, then the latitude of 0 degrees, which we also call equator, splits the Earth into two hemispheres, and this over here is the northern hemisphere and this over here is the southern hemisphere. The tip, so to speak, of the northern hemisphere is the North Pole, somewhere here, and it has a latitude of 90 degrees north. And the tip of the southern hemisphere is the South Pole, and it has a latitude of 90 degrees south. Also, all latitudes in the northern hemisphere are positive by convention, and all latitudes in the southern hemisphere are negative by convention. And this becomes important if you want to use trigonometric functions to carry out different calculations, as I did in my playlist on the Coriolis force, for example, so you can check that out. Now, in terms of the importance of different latitudes in atmospheric sciences and climatology, then indeed latitude of 23.5 degrees north and similarly negative 23.5 degrees are very important. This latitude in the northern hemisphere is known as the Tropic of Cancer, whereas this latitude over the southern hemisphere is known as the Tropic of Capricorn. And the region between the Tropic of Cancer and Tropic of Capricorn is known as the Tropics. Now you might ask, but why 23.5 degrees? It's such an odd number. Why not 25 degrees? There are two ways to explain it. The first way is to say the following. When we have summer solstice in the northern hemisphere on 21st June, then at noon of 21st June, at this latitude 23.5 degrees, the sun is directly overhead. In other words, on that day and time, this latitude 23.5 degrees receives the highest amount of solar radiation. Now you might go further and say why. Well, the reason for that will be explained in the next video, but shortly I can tell you that the reason is the tilt of the Earth's axis of rotation with respect to the revolution plane of our planet Earth when it is revolving around the Sun. Namely, the Earth, if this is the Sun, the Earth is not revolving around that, like that, but the axis is tilted, axis of rotation is tilted like that. And the tilt of this axis of rotation with respect to the vertical is 23.5 degrees. But that will become much clearer if you didn't understand it now in my next video. Another important latitude is indeed somewhere here at 66.5 degrees north and similarly 66.5 degrees south. Why is this latitude important? Well, again, if we attach ourselves to the summer in the northern hemisphere, then when we have summer in the northern hemisphere, each latitude will receive at least 12 hours of daytime. But the further north we go, the more daytime each latitude has. And when we reach 66.5 degrees north, all latitudes northern of this value will have 24 hours of daytime. In other words, this region north of 66.5 degrees will have polar day during the summer season in the northern hemisphere. The sun will be in the sky for 24 hours. In fact, of course, the sun will rise on the spring equinox on the 21st March, and it will not settle down for another 6 months. Now, going back to the concepts of tropics, subtropics, mid-latitude and polar regions, the region between 23.5 degrees and 35 degrees is known as the subtropics or subtropical region. And of course, the same applies for the southern hemisphere. The region between 35 degrees and approximately, or rather exactly, 60 degrees is known as the mid-latitude region. And I'm currently recording this video from a mid-latitude region because I'm perhaps somewhere here in Montreal. Montreal has latitude of 45.5 degrees, and that would be mid-latitude. I often teach course in Barbados, and Barbados is approximately 12 degrees north, perhaps somewhere here, so you can see Barbados is in the tropical region. And the region north of 60 degrees is known as the polar region, very cold region of our planet, and the same applies, of course, for the southern hemisphere. Now let us discuss the concept of longitude. We will start again by schematizing our planet as a spherical object, and the goal is again to split it in two hemispheres, but this time we are not splitting it into northern and southern hemisphere, but we are splitting it into east hemisphere and west hemisphere. So we take a line from North Pole and draw it to the South Pole. But the question is, where do we position this line? So through historical conventions, this line, which we call prime meridian, is passing through Greenwich in England, Royal Observatory in Greenwich in England. So maybe somewhere here is Greenwich, and then that's the prime meridian, and we call it 0 degrees. And then all longitudes between 0 degrees and 180 degrees are eastern longitudes, and by convention they are positive. And all longitudes between 0 and 180 degrees on the west hemisphere are by convention negative. And again, this is important if you use trigonometric functions. Now, we saw that latitude lines were parallel to each other, but longitude lines are not parallel. They instead have characteristics that all of them converge in the North Pole and South Pole. They look something like this. Now I can also add latitude of 0 degrees, namely equator. I can add another latitude here, and another latitude here, and another latitude here, and the same for the southern hemisphere. And this becomes familiar longitude-latitude representation of points on our planet Earth. So if we have if this is 0 degrees equator and I give you point over here, then you can easily find longitude and latitude of that point. Longitude is this, latitude is this. So you would say, for example, latitude is equal, let's say, 45 degrees north, and longitude is equal, let's say, 35 degrees east. You can also omit north and east, but then you have to make sure that you're using positive values for the north and east hemispheres and negative values for the south and west hemispheres. We will use these concepts a lot in the next videos and throughout this playlist, so please make sure to familiarize yourself with them. Also, please make sure to like and share this video, subscribe, share this video with your friends and family and enemies, and I will see you in the next video on the fundamentals of weather and climate. Until then, Goodbye.